Hello Pedram, today I am giving the presentation on assignment number 2. Task 1 is unsupervised learning clustering. So first import the libraries. The PIL import image library for open, save and manipulating the image. sklearn.cluster import k-means for the k clustering. Import numpy as np for statistical calculation. Matplotlib library for the visualization. So now open the image. We use the image.open code, and for to show that image we use the plot.im show code. So now here we can see the image. So now convert this image in a array. We use the np.asArray. So now finding the image shape and size, we use this code. So we can see the width, height and the channel. So now here we can see that width is 210, height is 210 and channel is 3. So now convert it into a two-dimensional array. So we use the code np.reshape, and here is the height, here is the width, and this is the channel. So now the our image shape is, now this is the pixel and this is the channel. So now k means clustering algorithm. Mention the number of cluster is 3. So the cluster is 3 and the random state is 32. So this is our output. So label the index of the cluster each samples. We use the k means dot predict. So now we get the label dot shape. So this is our output. So now reshaping the original image size, we use the labels dot reshape code. So now a particular section of the image use this code. So here we can see the some part of the image. So now we want to see the entire image. We use the same code as above. So now here we can see the whole image. So now finding the dominant color in the image, here we use the centers. So now we print that centers, and now we get the three arrays. So creating a 100 by 100 image to plot the dominant color in a block. This is the code, and now the first dominant color we get the light blue color, and now the second dominant color we get the black color, and for third dominant color we got blue color. So now the task 2, part 1 is load the data CSV file using pandas. So first we import the libraries, import pandas as pd, import numpy as np. To read the file, we use the pd.read, the excel format, and this is the path of the file. So now to show the first 10 rows of the data set, so we use the code over here df.head. So here we can see that is a 10 rows, and this is the index column. It is start from the 0. So now we want to drop the id column. So this is the code df.drop id, and axis is equal to 1. So now we want to see the information about the data set. So we use df.info. So here we can get all the columns name and then values. So for df.describe, this code we use for the statistical evaluation. So we can see all the statistical parameter over here, like mean, count, maximum, minimum. Third is examine the value of each attribute, and select a set of attribute only that would affect to predict dependent variable. So now we have selected diagnosis as a dependent variable, and rest all are independent variable. So now split the data between dependent and independent variable. So now first we import the libraries, and now here like y is a target column or dependent column, and x is a remaining column. So now the determine the data type of each attribute. So the diagnosis is a categorical data type. All other variables are continuous variable. So now converting the categorical value into numerical value using the label encoder. So now here we gave the label encoder and y is equal to target encoder dot fit transform. So this is the array we get as output. So now part 2 is split the data into train and the test data, and the ratio is 70% train data and 30% test data. So split the data into the test and the train data. This is the code, and then here we can see this is the column, 30 column. So now we see the normalization. For that we import first the all libraries. So for normalization, we use the scalar is equal to min max scalar, and fitting that model. So now label that encoding target encoder is equal to label encoder. So now y is equal to target encoder dot fit transform. So split the data into train and the test data. So this is our output. So classification of uh, for the classification we use the classifier is equal to SVC and classifier dot fit, that is X train and the Y train. So print training accuracy classifier score is a 0.98.99, and for the prediction we use the Y predict is equal to classifier dot predict X test. So print test accuracy, here we get 0.96.49. For display confusion matrix, first we import the library. So for that we use the Y predict and the X test. So this is the output. So second method is a standard scalar. For standard scalar transformation, first we give the like scalar is equal to standard scalar, and now the label encoding, and split the data into the train and the test data as above. So this is our output. This is the column, 30 columns. So now classification using the SVC and the print the training the accuracy. So here is X train and the Y train. So our output is 0.98 and 99. While the now we check the prediction same as the normalization method. So the Y predict is equal to classifier into predict that X test. So our output is 0.9649, and that is the same as a normalization method. So now we find the display the confusion matrix. So first we import the library, and for that print confusion matrix Y predict and Y test. So this is our output. We can fit any processing algorithm such as normalization and standardization based on the above accuracy. Both method observes the 96% test accuracy. So now import the library numpy as np. Now we creating the dictionary, and we have got a total of like 13 plus 13 26 hyperparameters, which make a total of 13 square. So it's 169 hyperparameter search space. So using the grid search, we are searching for the model with the best score in this search space that has 169 combination. So refit on estimator using the best found parameter on the whole data set. So now we fitting it to our data and searching for the model of all combinations. So now print the result pd dot data frame grid cv result, and the output is here. And so now the best parameter are with a score of 0.98. So for print the classification report, first we import the library and print the classification report Y test and grid prediction. So in the report we can see that 96 percentage is a testing accuracy and 98 percentage are a training accuracy. So now the benefit of standardization follows a Gaussian distribution. Outliers are not affected the result, but the disadvantage are it may be create a bias result, loss of information, mean and standard deviation. And the benefit of normalization, useful when data does not follow the Gaussian distribution, and the disadvantage of normalization, it will be affected by the outliers. Thank you.